This video is about the three main types of test infrastructure to test complex embedded systems. Full system, which represents the product. That means that all components of it are available and no simulations, etc. are involved. This is ideal to test the end-to-end behavior and also the validation of how the user will experience the product. The advantages here in terms of testing are that you test the actual product. As said, no simulations are involved, and it's also as close to the customer experience as possible. But on the downside, this kind of infrastructure is obviously the most expensive, meaning it has all the bells and whistles, plus it is therefore also the most expensive one. And besides the full system, there is of course also a partial system. Because for tests, it's not always necessary or even beneficial to have everything in place when testing. Especially integration tests may only require certain parts of the systems, which are in the individual cases then integrated. Therefore, the test infrastructure is more efficient and handy when it comes to comparing it with the full system. And it also can be flexible for certain product variants. But of course, on the other hand, as it represents only a part of the system, there is a part missing, and you have to therefore really know what to do and to make sure not to exclude the wrong things. And finally, simulations. So simulations in the context of system testing can be a very valuable addition. And of course also most of the times a combination of those three test infrastructure types are used to combine the advantages and to diminish the disadvantages. So simulations are used to simulate either the whole system or parts of them, which then allows independent and early testing. Simulations can be very quick and efficient in terms of test execution and also when it comes to the expenses for the test infrastructure. And it allows for scalable testing, because when you run simulations on standard computer hardware, you can scale it very easily. And also it allows for stable repetitions of certain tests. This may be especially relevant if you want to stress a system. The disadvantages are first obviously that you cannot incorporate the real environment. You somehow can simulate some environmental conditions, but not, of course, the real user experience. And simulations can have high maintenance efforts, because it's very important to always make sure that the simulation adapts to any product changes so that the right things are tested with the simulation.